All right, guys, so here's an explanation of that extra practice that I gave you on quadratics. So I'll go through each one. If there was one that you needed more help on, just feel free to fast forward to that part, but hopefully this helps you. So the first one talks about a quadratic function and it has its vertex. Remember, the vertex is the turning point. And so the vertex is at 1, -4. So remember, 1 is our x. So we go to the right 4, and then from that point we go down -4. So there's our vertex or turning point. All right, I'm going to put a V there. It says it has 1, 0 at 3. So that means that's along the x-axis. When it talks about a 0, that means an x-intercept. So it says it's at 1's at 3, right? So that means if this is the vertex down here, and this is one of the zeros or x-intercepts up there, that the graph has to have this kind of curve and open up, right? So what we know right now from previous lessons is that the vertex is the turning point, and from the right side and the left side from that turning point, it's symmetrical. And so we have that line is called the axis of symmetry. So if we draw that vertical line down the middle through the vertex, we can figure out what the other half of the graph would look like based on that symmetry line. So if I zoom in a bit here, from that axis of symmetry, it's 2 units to the right to get to the 0. So in order to get to the other 0, we got to move 2 units to the left. And then we can complete our graph. So if there's not a graph when you're doing a problem like this, just draw, a basic graph and do your best to count, space them evenly and make your own little graph there. Because visually it's so much easier to see. Hopefully that makes sense. So then find the other 0. So the other 0 is at -1. Explain how you find the other 0. Well, we plotted the points, right? And then after we plotted the points, we drew the axis of symmetry. I'm going to use AOS as abbreviation for axis of symmetry, and used the distance from the axis of symmetry to the first 0 and went the opposite direction to find the other. So that's kind of, sorry it's so sloppy, but I'm trying to write and talk at the same time. You obviously can reword it to make it your own, but that's kind of what we did, right? If you have other ways to do it, fantastic, as long as it's consistent with what this 0 was, right? So hopefully that makes sense for that one. The second one on there, remember I chose these because they're going to be similar. They're not just straight up like questions that you're going to be asked. There's some thinking that goes behind this, so I wanted to expose you to some of the possibilities so that you're ready for them when you get to the test. The x-intercepts of a quadratic, remember the x-intercepts, those are also known as the zeros, so those two words are interchangeable, are at 3 and at -3, all right? It says the y-intercept is at 6. Oh, goodness. All right. What are the coordinates of the vertex? Does it have a max or a min? And explain. So when I look at this, I'm going to ignore the y-intercept for a minute and just do a review of if I know the two x-intercepts, we've done these before, how do I find the vertex? And hopefully I hear you saying that we figure out the middle point between one x-intercept and the other. So this has a distance in between of, 1, 2, 3, 4, 5, 6 units. 6 units from one x-intercept or 0 to the other. That means that the vertex is halfway. So 6 divided by 2 is 3. So that means I go 1, 2, 3 units, and that is where my vertex is. All right, so again, we found the distance from one 0 to the other. And from there, we divided it by 2 because it's halfway, and there's our vertex, right? Now, let me zoom out a bit. What we should notice is that our, that our y-intercept is also in that same vertical line right here, that our y-intercept, so our y-intercept and our vertex line up along the same line, so that means that this y-intercept is also our vertex. And in order for that to be, this graph would have to open. So what was it? What? Which way? Down. Very good. Down like a frown. So, what are the coordinates of the vertex? The coordinates of the vertex are, if we write that as an ordered pair, x comes first. It does not move left to right, so that means that it's 0. It did move up to 6, so it's positive 6. There's our vertex. Does the function have a max or a min? This one has a maximum. Remember, max means it's the highest point. Minimum means it's the lowest point. So that's how you can tell the difference. Max is the highest, min is the lowest. And so this is the highest that it'll go, and then it turns from there. Explain how we knew. Well, again, the same thing. We can say we found the midpoint of the x-intercepts, and then it was the same x value as the y-intercept. So we knew it was the vertex. Whoops. We knew it was the vertex. Sorry. Hopefully you guys understand that. And again, we knew it was the max because it was the highest point. That's abbreviation for because. It was the highest point. All right? Lots of abbreviation that I used there. So hopefully that makes sense. Right? Both of these are very similar in the fact that we needed to figure out kind of distance going on here. Right up here at the first one, we had to go from the vertex to the x-intercept and then go backwards. And in this one down here, we had to figure out what's the distance between the two and go halfway. All right, the next kind you'll see is something like this, where you have to maybe fix a mistake, right? And so here's our original problem right over here. And so what they did, it looks like, is they factored this. Remember, factor means break it up into two things that will multiply to give you the original, right? So I'm just going to go ahead and do the work, and that's kind of my way of figuring out how they made the mistake. So I'm going to do it on my own, compare it to what they did, and figure out if they did it correctly. So I'm going to make my x for my factoring. And remember, a times c goes on the top. A is 1 here. C is 12, so we got 12 there. And b goes on the bottom. And as a reminder, a times c, what multiplies to give you 12 and adds to give you 7. So off the top of my head, I know 6 times 2 gives me 12. I know 1 times 12 gives me 12. And I know 3 times 4 gives me 12. Which combination would give you a 7 when you add? Oh, I don't, 6 times 2, I don't think that would work. 1, no. So maybe 3 times 4. Okay, so it looks like they also picked 3 times 4. Now the key here is I need it to multiply to give me a positive 12 and add to give me a negative 7. What's that? Ah, they both need to be negative. Very good. And so there, my friends, is where the flaw happened. They chose 2 positives. Right? So circle is step that the mistake was made. So I'm going to circle, 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 circle. Fix the mistake. So it should be x minus 4, x minus 3 equals 0. And finish solving. So I'm going to go ahead, and once I have it factored, we take each factor and we set it equal to 0. And we solve that. So our 2 solutions that we found are 4 and 3 because we factored it correctly. Remember, they made that one mistake here, chose the wrong signs, right numbers but wrong signs, so that was their problem. All right, last one. I'll create a possible equation for the quadratic in standard form, which is ax squared plus bx plus c. I don't know if you guys have done any like this, but I'll show you kind of the process that I go through. So here's our graph right here, right? And we notice that we're given a couple things. We notice we have two x-intercepts. One is at -1 and the other is at +3. We notice that here's our vertex at 1, -3, and this opens up, which means A needs to be positive. Really important there. So create a possible equation. So if it's like this and it's asking me to write it in standard form, the first thing I do is I find the zeros. All right, so find the zeros. So we have -1, 0, and 3, 0, right? 0 is also known as x-intercepts. So again, we can interchange those two words. Next is I write in factored form. So here's where sometimes people make mistakes, right? Factored form means I have one thing times another thing. So here's my question. If the 0 or x-intercept was at -1, what does that mean the factor had to be? And hopefully you say +1. And the reason is, if I were to go over here to the side and do x plus 1 equals 0, when I solve that, I need to get -1 as my 0 or x-intercept. And we do. So it's the opposite. When you write it in factored form, you do the opposite of what the 0 was. So same thing over here. If I need it to be a 3 when I solve it, what would I have as my factor so that when I solve, I get a +3? The opposite, a -3. So hopefully that makes sense. We make it equal to y, right? So that's our factored form. Now, the last step is to FOIL or distribute, whatever your teacher used as a terminology. So now we're going to take this and we go x times x, x squared, 1 times -3, -3. Now we do our inside, plus 1x minus 3x, still equal to y. And just as we've done before, we combine our like terms there. So we have x squared minus 2x minus 3 equals y. So that's one way to write our possible equation. So again, hopefully this helped. Let me know if you have any questions. I'm here for you guys. And look forward to making a couple more of these so that you guys feel comfortable when it gets time for the test.